All right, so in this video, we're going to talk about growth and decay. Introduction to the exponential functions. So it might not be easy to see. Let me see if I have here we go. This is a formula sheet. And we have the slope formula. Once again, you're singing when I'm teaching, Caleb.
Sorry.
Linear equations, you have the three forms. We did arithmetic sequences with linear equations. We haven't done distance formula midpoint yet. That's unit 7. We're in unit 5. This is your exponential functions right here. Thank you. Geometric sequence formulas, recursive and explicit. Caleb, I will personally send mom the video, because it is open to everybody that has the link. Recursive and explicit, and the compound interest formula. So we're going to take a look back at the arithmetic sequences, and we're going to learn about the geometric sequences, and that's it. Those are the only two sequences.
Okay.
And quadratic formulas right here with the quadratic formula. So average rate of change we've done. Statistics we haven't done. And we'll have to do the geometric part right here. Distance formula midpoint we haven't done. So one is unit 6 and the other one is unit 7, and we're currently in unit 5. Clear? All right, so this is the basic form, y equals ab to the x. What's different is that your variable is in the exponent area. A is a number, b is a number. They don't change. X is the one that is the input, y being the output. And we'll just have to get used to it. Famous compound interest formula. Here we go. That's what this y equals ab to the x is referring to, okay? All right, so here we go. This is y equals ab to the x. Now, it's going to be decay, exponential decay, as you can see right here. The main thing that makes it decay is that your b is between 0 and 1. This one right here. The a value only has to be positive. This is the a value. It has to be greater than 1, greater than 0, I mean. But b, if it's between 0 and 1, then we're going to have decay. For growth, it is the same thing. The a only has to be greater than 0, same requirement. But in the b value is going to be greater than 1. So when b is greater than 1, we're going to call that exponential growth. Now, I'm going to tell you something that hopefully we're not going to forget. The snackers, please stop with all that noise. B does not equal R. B does not equal R. I don't know how else to say it, except that B does not equal R. Please make sure that you wrote it down. Now, when you look at this form, you're saying, hey, Ms. Medina, what happened to the y equals ab to the x? Well, not much happened. We just rewrote it for growth. So if you look at it, everything still matches. A is still A. Oops, my bad. I meant to use the highlighter. A is still A, but we've rewritten B. B, we're now going to write it as 1 plus R. See, B is equal to 1 plus R. B is not R. This one is true. Okay. B is equal to the number 1 plus the value of R. It is not directly equal to R. There's a 1 there. In this case, that's for growth. For decay, B is equal to 1 minus R. So while you guys catch up in the notes, once again, A is still going to be A, but our B is going to become 1 minus R in decay. A is kind of like, we've heard this before, is your y-intercept, the initial value. So A is the y-intercept. R is the growth or decay rate, often as a percent. Yes, but we write it as a decimal, in decimal form. So cross this out. In the formula, it goes in as decimal form. And X is the number of time intervals that have passed. So if your rate is changing yearly, then your time is going to be in years. If your rate is changing monthly or being calculated monthly, then your time is going to be how many months, not how many years. If your rate is being calculated daily, then X is going to represent the number of days, not the number of years. So that's why they say the number of time intervals, because it depends on how you're calculating your interest. All right, here's an example. Let's see if we can understand these numbers a little bit better. All right, so in 1985, there were 285 cell phone subscribers. Underline. The number of subscribers increased by 75% per year. And this is something that you're going to have to get used to with the numbers. This says in 1985. This is when X equals 1. In 1985, that was the beginning. X equals 1. You're not going to plug in 1985. You're going to plug in 1. To 75%. How many cell phone subscribers were in Centerville in 1994? So that is the question. I'll just use pen, I guess. How many cell phone subscribers in 1994? Well, 1994, how many years since 1985? Please learn this method right now so that you always know how to figure out what the new X is, okay? 1994 minus 1985. Oh, I thought I had a license on this one. I guess it also expired. Are you okay? Because you were making weird noises just now.
No, I was laughing at you.
You were laughing at me.
Yeah,
Thank you, Jasir.
you don't have a license.
1994 minus 1985. I'm sorry that my paycheck doesn't cover enough technology tools for you.
No.
All right, what was it, 8 years? 9 years. So if you put it in a calculator, it'll give you 9, okay? So they want to know how many subscribers in 1994. Basically, X equals 9. Okay. And if we look over here, you will see that X equals 9 is blank. So let's figure out how they're calculating this. First of all, 75% as a decimal is
75 equals 0.75.
right. What is 75 of 498? So this is how we type it in the calculator, 498 times 0.75. And you have to make sure that you round it correctly. Just here.
No, where did I?
373.5. 374 since we're talking about humans, correct? What are we talking about? All right, so 75% is 374. So we added 374 subscribers the first year. So you need to do 498 plus 374. And how much does that give us? 872. Now, we're in the second year. What is 75% of 872? So 872 times 0.75. 654. Did we all agree? Was it rounded correctly?
Yeah.
All right, so what is 872 plus 654? All right, so we're adding the 75%, and it should give us.
1,526.
So this is what's happening here, exactly what the story says. Each year we're increasing by 75%. So we calculate the 75% and we add it to that year.
I passed